Hi everybody, welcome to the 5.4 and the 5.5 notes. This is about using the first derivative to determine local or relative extrema, and then we're also going to use the first derivative to find absolute extrema. So we're going to do something called a first derivative test, and what that is it says a critical point of f of x. So a critical point, remember, is when the derivative equals 0 or it doesn't exist. So a critical point is a relative minimum if f prime of x changes from negative to positive. And then a critical point of f of x is a relative maximum if f prime of x changes from positive to negative. So this is just like, over here on the left, this is f of x. So this is just like an original function, so no derivatives. But let's go here and let's look at this relative minimum right here. So we know that this is a relative minimum. And what we've learned about increasing or decreasing functions is wherever the original function is decreasing, the derivative is negative. And wherever the original function is increasing, the derivative is positive. So if you keep that in mind here, let's look at here real quick. Let's say that I have, so this first section right here is decreasing. So this whole section right here is decreasing. And so if I were to draw any tangent lines here, right, those are all going to be negative slopes, and so the derivative is negative. And then if I were to draw tangent lines here, those would all have positive slopes, and so the derivative is positive. So this section right here, we can tell that the derivative is negative, and then this section right here, the derivative is positive, and then we have a relative minimum, which is what our first example right there tells us. Same idea over here is that this section is increasing, so the derivative is going to be positive, and this section is decreasing, so the derivative is going to be negative, and then we have a relative maximum. And again, that's what our derivative says, is that, or our definition says, is that the derivative is going to switch from positive to negative. So let's do some algebraic examples, and then we'll also do some graphical ones. So as we do these ones here, it's really important, again, that you identify, what do I have and what am I looking for? And so this printed kind of weird on my side, but it says let f of x equals 1/3 x cubed plus x squared minus 48x plus 5. For which x values, so we're trying to just find the x values here, for which x values does f of x, sorry, sometimes the equations just don't stay in here. For which x values does f of x have a relative maximum? And then we have to justify our answers. And so where there's a relative, if we're given the original function, the place that we're going to see a relative maximum based on the definition is where the derivative switches from positive to negative. And so that's what we're trying to figure out in this problem. We're trying to figure out where does our derivative switch from positive to negative, because based on our definition of the first derivative test, that is where that will be. So since we have the original function, we start off by finding the derivative. So the derivative of 1/3 x cubed is going to be x squared plus 2x minus 48. Okay, and so to figure out where it's switching from positive to negative, we just use a sign test. So the first thing we need to do is basically figure out where does the switching occur. And the switching is always going to occur at a critical point, because a critical point is where the derivative equals 0, and so that's where it would cross the x-axis, therefore switching from positive to negative or vice versa. So I'm going to start by finding critical points. So I'm going to set this equal to 0. So I guess if we want like a list of to-dos, step 1 is find the derivative. Step 2 is going to be find the critical points. Find the critical points. And so for this one, I think we can factor here. We're trying to think about what multiplies to negative 48 and adds up to 2. And I believe that is 8 and 6, but then one of them needs to be negative, and so that would be 6, so that we could get to a positive 2. So I'll have 0 equals x plus 8, and then x minus 6. And so then my critical points are going to be x equals negative 8 and x equals 6. And so my next step after that is to do a line test to figure out where is the derivative positive and where is it negative. So the next step is a line test. So I know that there's potential, there's some chances that potentially that the derivative will switch at negative 8 and 6 because the derivative equals 0 there. I'm going to do exactly what I did when we were finding increasing and decreasing intervals. I'm going to plug in a number a little less than negative 8 into the derivative. I'm going to plug one into the middle and then one a little larger. So these are the numbers I'm choosing. As long as you choose a number smaller than 8, and sorry, I don't know why I chose 7. That's not smaller than negative 8. I'll choose negative 9. As long as you choose a number in that interval, it should be fine. So I'm going to use the factored form of the equation of the derivative because it's a little easier for me to use. So I'll have negative 9 plus 8 over negative 9 minus 6. And that will give me a negative number times a negative number, so this ends up being a positive. And again, I'm only concerned about the sign. I don't care what the number is. If I plug in 0 into this equation, I'll get 8 times negative 6, so that's a negative number. And if I plug in 7 into the equation, I will get 7 plus 8, 7 minus 6, which is a positive and a positive. So based on this, I see that my derivative is positive between negative infinity and negative 8, between 6 and infinity, and then it's negative between 8 and negative 6. And so based on my test, my relative maximums are going to occur when it switches from positive to negative. And so this is where it switches from positive to negative at negative 8, because it was positive and then it was negative. 6 over there, that actually is going to be a relative minimum, but it's only asking me about relative maximum, and I have to justify my answer. So I'm going to say relative maximum at x equals negative 8 because f prime of x switches from positive to negative. From positive to negative at x equals negative 8. Okay, moving on. So that's our first example. Let me know if you have any questions. So this next one says, let f be the differentiable function defined for x is greater than 0, whose derivative is given by f prime of x equals x squared minus 16 divided by x plus 2 for x is greater than 0. Find the x coordinates of the critical points and then classify them as a relative maximum, relative minimum, or neither. So one thing about this problem is we are trying to figure out where the original function has maxes, mins, or neither. But we're actually already given the derivative. And so our first step normally is to take the derivative, but we already have the derivative here, so we don't need to do that. So the first thing we need to figure out is it says find the x coordinates of the critical points. So find the x coordinates of the critical points. So we first need to look at that equation and find the critical points. And so the first thing that we can do for this one is identify whether there are any critical points because the function doesn't exist. And if I plugged in negative 2 here, I would be dividing by 0. And so you might think that's a critical point, but critical points only occur where the function is defined. And it says the original function is only defined for when x is greater than 0. And so that x equals negative 2 actually isn't even considered in our function. And so that actually is not a critical point. But therefore, we can go ahead and just set our derivative equal to 0 to see if we can find any other critical points. So I will multiply x plus 2 on both sides. These cancel out. And then these cancel out too, and I'll get 0 equals x squared minus 16. We'll add 16 on both sides, and then I can take the square root. You also could have factored. So I'll get plus or minus 4 equals x, because 4 squared would equal 16, and so would negative 4. So our two critical points are negative 4 and positive 4. And so I will go ahead and plug in. So I'm going to choose a number f prime of negative 5. I'm going to plug in f prime of 0. I'm going to plug in f prime of 5. So if I plug in, you have to use the original equation before you canceled anything out. So I'm going to do negative 5 squared minus 16 all over negative 5 plus 2. So on the top, I'm going to get a positive number, and on the bottom, I'm going to get a negative. So this is going to be a negative interval if I plug in 0 there. And also, I actually, just realizing this now, I don't actually even need to test this out because the function's not even defined there. It doesn't actually start being defined until 0. So technically, there would be a relative minimum there, but it's not defined for that section, and so that technically doesn't matter. If I plug in 0 here, I will get 0 squared minus 16 all over 0 plus 2, and so I'll have a negative over a positive, so this is a negative. And then here I'll plug in 5, so I'll get 5 squared minus 16 over 7, and that will be a positive or a positive. So I actually only have one critical point, which the critical point is at 4, and that's because -4 doesn't actually count because it's not within the definition of the function, which is x has to be greater than 0. So I'm just going to write that there's a critical point, or x equals 4 is a critical point, but it's specifically a relative minimum. And it's relative minimum because f prime of x switches from negative to positive. Okay, moving on to our next one. So this one's a graphical example. So this says the graph of f prime, so this is the graph of, this is f of x, is shown below for -6 is less than or equal to x, which is less than or equal to 10. Identify the x values of all the critical points of f and determine whether f has a relative maximum, relative min, or neither. So there are a couple critical points. So I'm looking for where the derivative doesn't exist, and I'm looking for where it equals 0. So let's start with where it equals 0. It equals 0 here, here, and here. And then it actually exists on all points. Some of you guys might think that it doesn't exist at 5, but the sharp point, when you're identifying whether a derivative exists, the sharp point would be on the original function, not the derivative. Technically, this point right here means that the double derivative doesn't exist, but not that the derivative doesn't exist. If the derivative didn't exist, we would see a hole in the graph somewhere here. So our critical points are therefore -3, 3, and 8. And so now we need to figure out which is which. So if I'm looking at this function right here, it is negative and then it becomes positive. So this is an example of a relative minimum. So there's a relative min at x equals -3. Let's keep going. Let's look at this point right here. So this point actually ends up being neither because it's positive and it's positive, and so there's no sign switch there, and so that one is neither because it doesn't switch signs. So that's x equals +3, and then this point over here switches from negative or positive to negative, so that one's a relative max. And then I have to technically give reasons, so I'm just going to explain them real quick. Again, so this one, the reason is it switches from negative to positive, positive to negative, and it just goes from positive to positive. It doesn't switch signs. So I'll add a note for this one. Doesn't switch signs. So that is a critical point, but there's no relative maximum or minimum. Okay, going on to the next one. So example 4 says identify all of the relative extrema of g of x equals x to the 4th power minus x to the 5th power. So again, we need the first derivative to figure this out. So the first derivative is 4x cubed minus 5x to the 4th power. And then I need to set that equal to 0. I'm going to factor out the greatest common factor, which is x cubed. So I'll get 4 minus 5x, and then I'll set x cubed equal to 0. And I'll set 4 minus 5x equal to 0. This gives me x equals 0. And this gives me 4/5. Yeah. So those are our critical points, and now we need to figure out, are the critical points extrema? So I'll do my sign test. So I'll have 0 and 4/5. Okay, so 0 and 4/5. So I'll start plugging in some numbers. I'm going to plug in -1 to see if the derivative is negative or positive. So it'll be, I'm going to plug it into the factored one too, because again, I just find that easier to work with. So this ends up being a negative number, and then this ends up being a positive number. So this is negative. I'm going to have to plug in like 1/2 here because I need a number smaller than 4/5, which is kind of annoying, but that's okay. So I'll have 1/2 cubed, and then 4 minus 5 to the 1/2 power. This is going to be positive. This is going to be 4 minus 2.5, so that's positive. So this is a positive, and then I'll plug in 1 over here. Sorry, g prime of 1 equals, it'll be 1 times a negative number, so that's negative. So those are our extrema. Well, that helps us find our extrema. So we're going to see here that there's going to be a relative minimum. And the relative minimum is going to occur at 0 because that's where it switches from negative to positive. Now, all the other problems just told us to identify whether the extrema were relative max or mins, but they didn't tell us to actually find the point. This one says identify all the relative extrema, and if it says something like that, it wants to know the x value of the relative extrema, but it also wants to know the y value of the relative extrema. So we know that there is a relative minimum at at 0. But we want to figure out what its y value is. And now we are trying to figure out what the minimum is on the original function. So we have been using the derivative to identify positive or negative, but to actually figure out what the y value of this relative minimum is, we need the original function. So we know where to look for it now, but we need to actually figure out what its y value is. So I'm going to plug in 0 to the original function, and I'll get 0 to the 4th power minus 0 to the 5th power, and that comes out to be 0. So the relative minimum occurs at 0, 0. And then 4/5 is our relative maximum because that's where it switches from positive to negative. And so we know that the x value is 4/5. Now we need to find its y value. And so I'm going to plug that in again to the equation, so to the original equation. So I'll have 4/5 to the 4th power minus 4/5 to the 5th power. And if you put that in your calculator, it should come out to be like 0.082. So that is the y value of my relative maximum. So that's my answer there. Okay, we're going to go on to, we have one more problem like this, and then we'll talk about one other like minor thing. So, okay, this is kind of more of a challenge problem, but I think you guys can do it. So it says, for what value of k does f of x equal x cubed minus 6x squared plus 9x plus k have a relative maximum of 10? So what we're going to do, just like always, is we want to figure out a relative maximum. We have to have the derivative. And so I know that there's like a confusing thing, like this is k, and then have a relative maximum of 10. That definitely is confusing. But if we want to figure out anything about this, we have to have the first derivative. So I'm going to start by taking the derivative. And feel free to try this on your own if you feel ready. Okay, so the k actually disappears here. So you might be like, what is happening here? But it'll work out. So if I want to figure out, well, I'm just first want to figure out like where does the relative maximum even occur? And so I'm going to find the critical points, and I'm going to use that to find the relative maximum. So if I look here, I can factor out a 3. And I'll get x minus 3, x minus 1. So my critical points are occurring at 1, 3. So let's just try to figure out where are the relative maximums. Okay, so I'm going to plug in 0 to this function. I'm going to plug in 2, and I'm going to plug in 3. So if I plug in 0, I should get out 9, which is a positive number. If I plug in 2, it'll be 3 times a negative number times a positive number. So this will be negative. And if I plug in, sorry, I can't plug in 3. I need to plug in 4. To the derivative, I should get 3 times a positive times a positive. So the relative maximum is occurring at 1 because that's where it switches from positive to negative. So I know that their x equals 1 is a relative maximum. So if I know that this is a relative maximum, is a relative max, now I want to figure out, okay, so the relative maximum is at 1, and it says that the relative maximum, if it has a relative maximum of 10, what that's implying there is that's the y value. So I know that the point is 110. So I just need to figure out what the k value is so that the point is 110. So basically, I know that the function is going to equal 10. I'm going to plug in 1 for x because that's where the relative maximum is occurring. And then I'm going to solve for k. So I'll get 10 equals 1 minus 6 plus 9. I'll get 10 equals negative 5 plus 9, which is 4. And then if I solve for k, I'll get 6 equals k. Okay, we have 2 more examples, and then we're done. I know that these are kind of long. It'll be okay. So now we're going to move on to something called the absolute extrema. And so I'll go through some steps here, but the last couple problems, we've just been figuring out the relative extrema. So we've just been figuring out, like, if I'm looking at a graph, what points are relatively higher than the others. So that was a bad example, but like relative extrema, like for example, this one right here is a relative extrema because it's relatively higher than the other points. But now what we're going to be doing is trying to find the absolute extrema. So like, for example, this point that I just drew is the highest point, and so that's what we're going to figure out. So a lot of this process is exactly the same. So I'm going to kind of write out our process as we go. The very first step in finding the absolute extrema is to just find where extrema are occurring. So you're going to start by finding critical points. So we're going to start by finding the critical points. And so I first need to take the derivative. So I'll get y prime equals 14 times 3 is 42, so 42x squared plus 22x minus 4. As I look there, that has a greatest common factor of 2. So I'll get 21x squared plus 11 minus 2. And then my a value is still not 1, so I have to factor by grouping. So I'll do 21 times 2, which is negative 42. And I'm thinking, what multiplies to negative 42 and adds to 11? That is 14 and negative 3. So I'm going to factor by grouping. So I'm replacing the middle term with 14x and 3x. And then I'm just going to keep factoring. Okay, set that equal to 0. And so if I solve in my head, I'm going to get that my critical points happen at negative 2/3 and 1/7. And so those are potential places that there could be some relative extrema. And so relative extrema could also be the maxes and mins. And so what I'm going to do now is I know that there could be some relative extrema there. So I'm going to do something called a candidates test. So I'm going to write x, and I'm going to go y. Okay, and so I know that there is potentially a absolute extrema at negative 2/3 and 1/7, because those are critical points. So those are options. But also, technically, the end points could also be relative extrema, because if you looked at this example that I drew over here, the highest point was actually the end point. And so I'm going to do something called the candidates test, and I'm going to test out all of these values. So there could potentially, and I'm going to make my chart low to high, so there could potentially be an absolute extrema at negative 1. There could potentially be one at negative 2/3. There could potentially be one at 1/7, and then there could potentially be one at 1. And I'm just going to use my calculator, and I'm going to plug all of those values back into the original function. And the reason I'm plugging them into the original function is because the original function is going to tell me what are my high points and what are my low points. So I'm going to do that real quick. And also, if you want to take a cheat, you can always use your table function on your calculator to make this go by a little quicker. And so that's what I'm going to do. It will just kind of quicken the process. And if you can't remember how to use your table, just let me know and I will help you with it. So using my table, I'm getting 4 out here. I'm getting 6.407 here, 2.694, and then 24 here. And so based on that, I'm just looking for the lowest value and the highest value. So this is my highest value. So there is an absolute max at 124. And then my lowest value is this one. So there's an absolute min at 1/7, 2.694. And that's the answer to that one. So again, we'll do one more example. And this says find the absolute extrema of this function right here. So first thing, and specifically there is a interval. It's negative 2 to the 4th power. So we're concerned on those bounds too. So I'm going to start by finding the derivative, and that's going to be f prime of x equals negative 12x cubed plus 24x squared plus 36. I'm going to set it equal to 0. You can try this on your own if you want to. I'm going to pull out the greatest common factor, which is 12. I'm going to pull out a negative 12 because the leading term is negative 12. Oh, and sorry, this should have an x on it. I'm going to pull out negative 12x. Get x squared minus 2x plus minus 3. Yeah. Okay, and then I can factor what's inside the parentheses really quickly. It'll be x minus 3, x plus 1. So my critical points are at x equals 0, 3, and -1. And then I also have endpoints, and those are other places there could potentially be an absolute max or min. So my options here are x, f of x, -2, -1, 0, 3, and 4. And again, I'm going to use the calculator function, or like the table function, to figure out this really easily. But I'm plugging in the original function into my calculator because I'm concerned about what's the highest points and the lowest points on the original. Using the derivative essentially just tells us where we're supposed to look for those points. So I'm typing in the original function real quick. And then I'm typing in my values. Oh no, I pressed the wrong button on my calculator, so give me a second. Okay, so I'm typing in -2, -1, 0, 3, and 4 into my table. And I'm getting out -40, 7, 0, 1, 35, and 32. And so my low point happens to be at one of the endpoints. So this is my absolute min. And my high point happens right here, and that's my absolute max. And that is our answer. So that is it. That's all you have to do. Let me know if you have any questions on any of these notes, but that is it for the day. Thanks.